Hello, hi everybody. Welcome to the May 2024 edition of the Azure Functions Community Call. Today you have me, Thiago Almeida, Madhura, and Ramya. The three of us are PMs on the Azure Functions team, and we're very excited to give you an update on recent things that came out for Azure Functions, but also two specific features of Azure Functions that we would love to give you more insights on and maybe a demo or two. So with that, let's get started. I'm just covering this slide. We have just a few updates since the last time we had a community call, which was in February. We have a few retirements coming up that we wanted to make sure that everybody is aware of. We usually with Azure Functions, we keep the support for different language versions together with when those languages will end their support as well. So for .NET 6's end of life is on November 2024, and because it's an LTS, it ends after .NET 7, which was a short one, and both of those are ending support this year. So the recommendation is to upgrade to .NET 8. If you go to the link that's at the bottom of the slide, aka.ms/Azure Functions News, you will have a link to a blog post that has one link for each one of these entries here as well, in case you need to know a little bit more. The next retirement that I wanted to call out is the in-process model for .NET apps. As you know, at the moment, we have both in-proc and out-of-proc as different models for .NET, and the end of life for the in-proc process model will be November 2026. So you have some time between now and then to migrate your apps from in-proc to out-of-proc, but that's definitely a recommendation and a project that I would recommend that you focus on if you have any .NET applications running on Azure Functions. And finally, if you use Service Bus and you are using an older extension version, like V4 and older, you should upgrade to the latest Service Bus extension V5 because the older versions of Service Bus extension will be unsupported after March 2025. Finally, on new features, triggers and bindings, we went GA with the Azure SQL trigger support for Azure Functions. And for that, now you can trigger from Azure SQL Server directly from your function apps. There's only one in consumption that the scaling won't scale for it, but for all of the other hosting plans, premium plan and app service plans, those will scale appropriately. So please give it a try. It would be great to get your feedback on this item as well. And I know that Azure SQL has been a much asked feature for functions to integrate with. So we're happy to bring this to you. And finally, on the languages updates, we have the public preview of PowerShell 7.4 support. This is the latest and greatest PowerShell version that we are supporting. We also went GA with the support for Node.js 20 LTS. And one more item, which is the next topic for this session, is the public preview of Azure Functions support for HTTP streams in Node.js. So streaming through HTTP in Node, which has been a very much requested feature that we've had. And we have Madhura with us today to give you a deeper dive into that. So with that, we'll switch over to Madhura to take over and talk to you about that feature. Take it away, Madhura.
All right, thank you so much. Thanks everyone for joining today. As you know, my name is Madhura. I'm a PM on the Azure Functions team, and I work on Java, JavaScript, and VS Code extensions for functions. Today we're going to talk about HTTP streams with Node.js for Azure Functions. Let's talk about the what, why, and the when of this feature. This feature has been a long time coming and has been one of the highest requested features, as Thiago just mentioned, for Azure Functions in general, but specifically for Node Functions, this has been highly requested for a long time. JavaScript users are not new to the concept of HTTP streaming. It's essentially a mechanism for transmitting data over HTTP in a continuous and efficient manner. Instead of sending all the data at once, streams allow you to send the data in small, manageable chunks. This can be processed as they arrive. Now, as you can imagine, this process has several benefits. The first one, we're talking about efficiency here. So streams reduce memory usage and improve performance because you can process data as it's received, as I just mentioned, rather than waiting for the entire payload to be transferred and then they get some action on it. Streams also helps with scalability in that it enables you to handle large volumes of data without requiring excessive memory or processing resources, which make them very well suited for scalable applications like your serverless functions. And lastly, we're also talking about the ability to real-time process and analyze, so your applications can react dynamically to incoming data. Talking about the why, or what scenarios can you use this for? This feature is commonly used for various purposes such as file uploads, large file downloads, real-time communication, multimedia streaming like audio-video streaming, server-sent events. They're particularly valuable in scenarios where you're looking for low latency, high throughput, and efficient resource utilization in general. So with added support for streams, Azure Functions becomes a perfect candidate for these scenarios. You can try this feature out today with functions. For example, you can stream OpenAI responses with your Functions app. So try that out today, and I'll show you shortly how you can do that. How you can use HTTP streams in general. Currently, this feature of HTTP streams is only supported for JavaScript functions, although we do have it on the roadmap for all of our other languages as well. And you can shortly expect to hear from us about those languages also. So next is the when. I think this is the part where what everyone's waiting for. We already announced preview for this feature in February. So this has been out there for a while. And you can learn more about it and try it out today on this aka.ms link that's on the screen right now. It also has a link to easy to download and run demo that you can use to check the power of streaming today. I want to take you through a live demo and show you how streaming works. But before that, it's good to go through a few prerequisites. HTTP streams for JavaScript is built on top of the latest Node programming model, the V4 model. So make sure you upgrade your apps to use the new model if you haven't already, so that you can leverage this feature. I've also left a link there right below the Node.js Functions programming model. That is the AKA link that will tell you all about the new model and also how you can upgrade if you're still on the V3 version of the model. You also need to have a version 4.3 or above of the NPM package, Azure Functions NPM package. If you're running on Azure, then you need to be on 4.2.8 at least of the Functions runtime version. And Azure Function Core Tools version is also as mentioned on the screen. So these are the prerequisites. I haven't particularly called out the Node language version itself because we support Node 18 and 20, which are the two LTS versions that are generally available right now, and this feature works in both of those languages. So if you have a Node 18 or 20 app today, which is running the V4 model, there's nothing stopping you from trying out streams. And I'll show you shortly how you can also, with just one line of code, upgrade your app to start using streams today. Let me switch to the demo. Please bear with me for a second. All right. Okay, so on my screen, you see a Node V4 programming model project. I have two functions, stream request and stream response. Stream request receives a post request a streaming post request, and stream response basically will demonstrate how you can respond to a GET request with a huge, with a stream of data. We'll look at both of these scenarios today. I basically have two terminals here. One is running the function itself, and the other one is for me to run scripts. So I can send the request to both of these functions. I also have an npm watch running in the background, so I can compile as and when I make changes. With that, let's look at I'll talk about this shortly, but let's look at the behavior today. Let's say your app does not have streaming enabled yet. Today, if you make a request with the header transfer encoding chunked, and if you make a send request, this request basically fails with error as you're seeing on the screen. And this is the response. You get a 500 internal server error because your function does not know how to handle the header transfer encoding chunked. And this has been a huge problem for a while. The first advantage that you'll immediately see by turning on streams is that this header is now supported. I have an output file that you can see is empty right now because the HTTP, we received a 500 error. Let me project the output file on the screen. Yes. As you can see, it's empty right now. Now, what I'm going to do is I'm going to turn streaming on. Now, this is all you need to do to turn on streaming. You just need to have this Boolean enable HTTP stream equal to true in one of the files that is included by your main field. And as soon as you do that, your project is now upgraded to using HTTP streams. So I did that, and you see my worker process initialized. Like I said, this happened because I have an npm watch run watch task running at the background, which is why this was able to pick up the changes. Now, with streaming turned on, I'm going to send the exact same request that I did before with the body as the summary of a children's story that my son likes. I'm going to send the request. And as you can see, this request was executed, and we got a 200 OK. And the output, this was just for our reference, the output is exactly what we sent in the body of the request. So the first advantage, as you can see, is it supports transfer encoding chunked. You can also see this is how simple it was to upgrade your project to support HTTP streams. Now, I think to unleash the true potential of streams, we need to actually start sending larger data to see how streaming exactly works, right? So we have streaming turned on. I have an input file that is a 200 MB file, which has some text that is repeated multiple times just because I wanted to make it 200 MB. What we're going to do is we're going to run a script called stream request, and we're going to send this 200 MB file as an input to our stream request function. So I just ran the function. I just made a request to that function. Let's see if it picks that up. As you can see on my terminal on the left, function is receiving this request in streams. And you can also see on the output window on the right side that this request was received. And yeah, I think we'll see the progress. Okay. So just before this demo started, I had increased the size of the file to 500 MB. So as you can see, this is a 500 MB file that we were able to stream into the function with. It took about 20,500 chunks to be able to stream this request. So now that we've seen how to stream requests, I think we also want to see how to stream responses. And with the stream response, I really like to show you the difference in performance. You can still screen my screen. Apologies for that. My VS Code window just did not like what I just did. So my screen is loading. Apologies.
And Madhura, while that loads, a question I had was, what types of solutions that you've seen customers that wanted this feature do it for? Is it usually uploading files through a web solution and then streaming those files into blob storage, for example? Or which other scenarios do they follow?
Yeah, exactly. I've seen some. Yeah, I've seen some customers do that. I've also seen customers using this for OpenAI streaming, because OpenAI responses usually tend to be a little slow. But to be able to action on the responses as and when they arrive, and not having to wait for the entire response to be ready from the OpenAI side, I think that was one of the biggest asks, even on our GitHub page, that they want to be able to use it with OpenAI. So they use it for that. I've also seen some customers use it for requesting it for multimedia streaming, like I mentioned before. So yeah, what the scenario you mentioned and all of these other ones as well.
Great. And you said that your demo on a sample that we could look at, or
Yeah.
you plan to put it?
Yeah, it is. Correct. At the end of this, at the end of the stream, I'm going to show you how you can access this and how customers can make use of this sample right today if they wanted to. So I'm running an HTTP response streaming function now. I'm not sure if my screen is updated. Oh, I think my screen is not getting updated. I might have to reshare. Apologies for that. It's just going to be a few seconds. Okay, there we are. So what I just did is I ran the HTTP stream response function. What this function basically does is it picks up the 500 MB file that we had, and it streams the response into it responds to the user, whichever made the GET request. So as you can see, it was able to stream a 500 MB file. Basically, the user was able to download the 500 MB file. In the interest of time, I'm just going to change the size of this file to 200 MB, so we can test how this works with and without streaming. So I have a script that helps me generate an input file. So this script is generating a 200 MB file for me, so I can just stream that. So what we're going to do now is let's turn off streaming so we can compare the performance of this function with streaming and without streaming. So right now streaming is turned off, and I'm going to be making a request to the response function, and we'll compare it with and without streaming. In the meantime, if you have questions, please put them in the chat, and we can take those questions at the end. So I'm running the npm run stream response script now. This function will start streaming the 200 MB file. All right, as you can see, with streaming turned off, it took about 11 seconds to stream the 200 MB file. Now, let's turn streaming back on. It's essentially the same input file that we've given. And let's see if the stream is starting shortly. Yeah, and the stream response took 5 seconds this time. So there's a significant, almost less than 50% of time that it took to stream that file. So as you can see, in terms of performance, in terms of the ease of upgrading, and also in terms of support for transparent coding chunked, and you would also see out-of-memory exceptions in the past without streaming when you send file as a huge chunk. You're not going to see that anymore with this feature turned on. So feel free to go try it out today. And I'm just going to switch back to my presentation quickly. I just have a very few quick points to call out. So as you saw in the demo, in terms of, like I said, performance and all other good things, you can go try HTTP streams today. And like Thiago was asking if there's a link where you can go try the sample that I just demoed, you can go check it out at aka.ms/Azure AZFunk node HTTP streams. There's a link to a repo that has the sample and also the benefits of using streams and all other good details. We're also going to be announcing the general availability for this really soon. So be on the lookout for that. We've already heard some good feedback, like I mentioned before, and we're excited for you to try it out. We also want to hear from you, your experience of using the Node v4 programming model. So here's a link to the survey that you can take, aka.ms/functions node survey. Let us know what you think, and you have the power to shape the roadmap of JavaScript functions with this survey. With that, I will hand this over back to Thiago. Thank you very much.
Thank you, Madhura. That was great. And thanks for sharing the link. I'll have to check it out as well. Cool. So with that, our next section is with Ramya. We're going to cover functions on Azure Container Apps, which is currently in public preview. And Ramya will give us an update on this. So go ahead, Ramya.
Hey, thanks, Thiago. Yep, sure. Thanks, Thiago. Yeah, a lot of exciting stuff happening on the functions world. You just heard from Madhura on the HTTP streaming, and you also heard from Thiago on the whole set of new things that are already released, and we have a bunch of stuff coming this month. So stay tuned. And as part of this, I'm super excited to talk about Azure Functions on Container Apps. I'm Ramya Oruganti, currently working as a product manager with Azure Functions team. My focus areas are enabling functions on Kubernetes-based environments. As part of this, we've come across several customer use cases who run functions as containers, packaged with custom libraries, or they're using functions as microservices, right, in a microservices workload as such. So as part of this, customers were facing challenges with managing the underlying Kubernetes clusters, getting the Microsoft support on the OSS components they use, along with the functions program and code, and also this is kind of increasing their operational costs. So to kind of address this feedback, so we've come up with a new hosting option called Azure Functions for cloud native microservices, and this is hosted on Azure Container Apps as such. So this is a new hosting option of Azure Functions, which offers this new and flexible way for customers to build those cloud native, event-driven function apps. So this hosting allows developers to run functions alongside microservices, APIs, websites, workflows, or any programs hosted on containers. Or if customers have requirements to package custom libraries along with functions, they could do that, and these functions can be containerized and hosted as containers on this new hosting option called Azure Functions on Container Apps. So it offers a suite of features and completely managed and supported by Microsoft. So this includes the functions programming model, the functions extensions, the triggers and bindings. It also supports the platform managed scaling, which is powered by the seamless integration with Keda, where customer need not configure the scaled objects or scaling rules to scale their function apps, and supports various CI/CD and DevOps tooling like GitHub Actions and Azure Pipeline tasks within the container apps environments as such. So you can have your functions running in a unified app environment, coexisting with other web apps or APIs or microservices as well. And these APIs and microservices can be written in different languages in a polyglot fashion, and still these various functions and APIs can interact together irrespective of the language that they're written in. So there's several. It's currently in public preview. So we've launched it in May 2023 during the Build conference, and post that there have been several enhancements that was done to this hosting option, and we are also going GA soon this month, and we'll be announcing more features, and I'll provide a quick flash of features that's going to go GA as well. But in the current preview state, so the platform managed scaling support for timer trigger is now available. This will enable you to run functions on a schedule, scale from, and it helps functions scale from 0 to 1 and back to 0 once the execution completes. So as you can see, this eliminates the need for customers to configure any of the like Keda scalers or min replicas as such. So it's all platform managed. And then the other cool feature is about the support for workload profile environment, right? So Functions on Container Apps now supports consumption plan and dedicated plan across workload profiles within the same Container Apps environment, right? Like you could have like like different container apps running functions with multiple plans, right? Like one of your functions could be using consumption plan, and the others could be on dedicated plan. So as you can see, it gives you the option to run Azure Function apps on dedicated, and this also supports GPU compute, and I'm going to talk more about in a moment. And with the dedicated compute, there are range of compute sizes. Also with consumption, there are range of compute sizes that customers can choose, profiles of CPU and memory that are available, and customers can choose from a range of CPU memory combos. Apart from this, the Dapper extension for Azure Functions is also released in public preview. So this enables a seamless integration with Azure Functions on Container Apps, enables users to build functions that react to events that are generated from Dapper or from external systems. So, and it helps facilitate integrations between functions and other microservices as well. because Dapper provides those best practices for distributed microservices development, and you could leverage the Dapper extension with Azure Functions for that. And the key ones are you could use the Dapper extension for service discoverability, PubSub, and bindings. And as you know, Azure Functions already supports a wide range of bindings and triggers, so you could continue to do that. But for the bindings, right, which are not available out of the box, you could leverage, the bindings from Dapper in those cases. And finally, you can now create and deploy your function apps on Azure Container Apps environment using Functions extension in VS Code. So this really accelerates the speed of deployment of your functions on Container Apps hosting option. Moving on to the next slide, I'm super excited to kind of show you the demo. This is going to be on how to deploy the timer trigger function app on Azure Container Apps hosting environment. Moving on to the next slide. So imagine a situation where you need a process to be executed on a schedule to perform tasks such as cleaning up databases, sending emails, processing data, generating reports, or performing health checks, right? And if this particular app needs to be deployed onto a microservices environment, so such a process can be executed using the timer trigger function app. So here I have in this example, I have a timer trigger function app, which is scheduled to execute every 12 minutes. So I think it's just passed over. So this needs to be played again. So Thiago, if you don't mind, if you could, go back. So Thiago is kind of supporting me to run this thing because I really wanted to show the live scale up and scale down of the service. So the best way to kind of do that is to kind of capture it in a demo video recording. So hence it's there. So here, as you can see, it's a function app written in C#. It's a simple timer trigger function, which is scheduled to execute every 12 minutes. And once it executes, it displays the message on a successful execution. Now, this is, packaged and the image is pushed to the ACR. So, and then using the Azure portal, let's see how to create it on a function app running on Azure Container Apps. So you go to the Azure Functions create page and, choose a subscription resource group and then create a container app environment. So in the environment, you choose a workload profile. So here you get to choose between, like, the consumption is there by default, but you could also choose a dedicated compute. So for that, you first choose the dedicated compute option. As you can see, there are GPUs compute available. So this is suitable for, use cases such as large image video processing or training your LLMs or SLMs on demand. So you could use functions for those use case scenarios with high GPU requirements. And then, so for this demo, we'll, go ahead and create this environment and then choose a default storage account and the app insights workspace so that we could monitor our function apps. And then in the deployment tab, let's provide the image that was pushed to the ACR registry. So here it's actually a private registry. So you're expected to provide the registry credentials, the image, the tag, and the registry login server and the username and password as such. And then here you get to choose the the configurations, right? The CPU memory configurations. So for this demo, we'll choose the consumption plan and choose a profile and submit it for deployment. So once it gets deployed, here in the configuration tab, you could actually change the image if you want in a future state. And then let's go to the App Insights live metrics. And as you can see, there's a past log trace here. The timer trigger executed after 12 minutes and logged the message. And as you can see, once the schedule happens, the pod comes up, it executes. And then once the execution completes, it goes back to 0. So it works like a charm and it executes as per the scheduled time. So as you can see, right, so the execution completed and it scaled to 0. So yeah, so stay tuned. We'll be shortly launching the service, which is currently in preview to the GA state. We are also happy to introduce capabilities to enable that secure access from Functions Container Apps to Azure AD protected resources using the managed identities. So the MI support will be out along with the GA launch, and we will also provide the ability to deploy your function apps in a VNet internal based container app environments. So this will enable you to deploy your function resources in a private VNet. You could bring your own private VNet and deploy your function on container apps resources into this private VNet as such. So this will be launched during the general availability release. So yeah, moving on to the next, right? So check out the service and features that are available. Let us know what you think. Give us your feedback, what worked. So here is a survey link. You could provide your feedback, and do check out our GitHub repo samples, right? There are several samples out there, bicep templates, the AZD templates, the timer trigger sample is out there. So please do check out. And if you have any feature requests or issues, you could log them in the GitHub repo as well. Yeah, so thank you so much, and look forward to hearing more from you on Azure Functions.
Great, thank you, Ramya. And I put here on the screen also a short URL for the survey in case people can fill it out. That would be great. aka.ms/funcom.aca feedback. Thank you, Ramya. And
thanks, Thiago.
Also, thank you, Madhura, for joining us. That's all we had for today. Really hope that you are as excited as we are for these two features, HTTP strings on Node and also running functions on container apps with the other microservices that you can host in this hosting option. And with that, we are done. A reminder to go to aka.ms/Azure Functions News. That will have the recording of this video, but also links to all of the new updates that we've had recently as well. So thank you, everyone. Thanks for joining and watching and checking out these new features. We're here, and we'll be back next month or the month after to give you any updates. Of course, we have Microsoft Build coming up in a couple of weeks, 2-3 weeks from now on May 21st. So there's definitely going to be some news there from Azure Functions, and we'll do a recap of Build news in the next stream, most likely. So thank you, and see you then. Bye.